Hw2 Question 1. This problem has us calculate density for each of three objects. The formula for density is not that tricky. It's just mass over volume. But they make you fish for the data pretty carefully in this data table. And that's the tricky part. And they also want you to calculate this to the correct number of significant figures. So let's start with the first item that they give us is dry sand. So we're going to calculate the dry sand density. But we've got to get both its mass and its volume. To get the mass, check out the second number down in the data table. That's the mass of the cylinder with the dry sand in it. And the third number in the data table is the mass of the empty cylinder. Just subtract those two. The 37.3488 minus 22.8317, and you get 14.5171 grams. There's your mass of the dry sand. Now for the volume. They give us, thankfully, they give that directly to us in the data table. 10.0 milliliters. Notice that 10.0 milliliters is a number that's good to 3 significant figures, whereas the mass is good to 6 significant figures. When we go to calculate the answer, you must answer to the fewest number of sig figs as you find in any of the measurements that you're multiplying or dividing together. So on my calculator it reads 1.45171, but I've got around that in the final answer to just 1.45 grams per milliliter. You can write that in the box, 1.45. Now let's talk about methanol. The methanol's density is going to be a mass over volume, just like that for the dry sand. To get the methanol's density, we need to look at two numbers. First of all, the mass of the cylinder plus the wet sand. So if you think about that, that's the sand, the dry part of the sand, plus the cylinder, plus the wetness due to the methanol. And then this other number directly below it, 37.3488, that's just the cylinder plus the dry sand. So if you subtract those, you should get the mass of the methanol. So I'll take 45.2613 minus 37.3488. And that should give us the mass of just the methanol alone, 7.9125 grams. Okay, so if we record that mass, we've got the mass of the methanol. The volume of the methanol, thankfully they just give it to us in the table, 10.00, and they gave us this number to 4 significant figures. So if you calculate that, 7.9125 divided by 10, on your calculator it's going to read 0.79125. The mass is good to 5 significant figures, and the volume is good to 4 significant figures. That means that the density may be recorded to 4 significant figures, and that gives you 0.7913. So we can record that 0.7913. And lastly, they ask us to find the density of the sand particles themselves. So what's the difference between dry sand and sand particles? Well, if you read the story problem up there, they tell you that the sand methanol mixture was stirred until bubbles no longer emerged and the sand looked uniformly wet. So when they say sand particles, they mean use the data for dry sand except ignore the bubbles. Your mass is going to be just the same as with dry sand. So sand particles would have a mass equivalent to that that we found for the dry sand. The density would be 14.5171 grams. And then we need to look for the volume. Now there's two numbers we need to look for when considering the volume of the sand particles. Okay, so those numbers are the volume of the sand plus the methanol and the volume of the dry sand. If you can subtract those two numbers from each other, you'll get the volume of the sand particles themselves. So 17.6 minus 10.0 gives you 7.6 milliliters. That's the volume of the sand particles themselves. And if you divide that out on your calculator, it'll read 1.910. But keep in mind sig figs. The mass is good to 6 sig figs, and the volume is only good to 2. So you've got to record the density as just 1.9 grams per milliliter. And you can fill that in below if you want. Lastly, they ask you, does the bubbling that occurs when the methanol is added to the dry sand indicate that the sand and methanol are reacting? That's a very interesting question. In this case, no. There's nothing that the bubbling indicates except that there were air bubbles trapped in amongst the sand particles. However, I would note that normally the presence of bubbles is an indication that a reaction is happening. So keep in the back of your mind, I guess, that bubbling is an indication of a reaction occurring, but in this case, it's not. So I'd click the no button, and we're done with this problem.